Hi and welcome. My name is Bob Deibner, a Senior Applications Engineer at Corellis. In this presentation, I'll be showcasing ScanExpress DFT Analyzer, which provides test coverage statistics and details for tests created with our ScanExpress TPG boundary scan test environment to help you measure your boundary scan test coverage. Let's get started. So ScanExpress DFT Analyzer takes input files that ScanExpress TPG is going to create and creates testability reports. When we say testability reports, we're saying it's going to tell you what kind of open and short type coverage you will get based on the test that you've generated. There's an integrated report browser. These are CSV files, so in addition to using our browser, which is very simple to display them, you can also load them into something like Excel. I've been known to load these into Excel, create pivot tables and pivot charts based on them. Or if you have a database that you'd like to load this into. The CSV is a great neutral format. We do recommend, if you can, develop a test procedure after schematic and prior to layout. And then you can get an idea of what kind of areas you're missing coverage in before you go to layout, so that you might be able to make changes at schematic level prior to committing to layout. If you need to edit the reports, if it's and you don't want to use this just to edit the reports to make them look better, of course, but if you need to remove a device, maybe there's something that's part of your test jig that's also boundary scan IO and is being counted, you can use the report edit to modify that and make sure that your coverage reflects reality. It's very similar to the constraints interface in ScanExpress TPG. And that's it for the presentation there. So we're going to move straight on to the demonstration. So I have generated these test steps in ScanExpress TPG. Now I should see somewhere in here that it created report files. Because it didn't, that means I must have it turned off. So if I go to Tools, Preferences, I change this option, Generate Test Coverage Reports, and then I regenerate. There we go. So I now see generated testability report file, and it tells me where that file is. If I click reports here, it will launch ScanExpress DFT Analyzer. It will load in those RPT or report files. And let's make it so we can see this on the screen. So it's giving me coverage for interconnect, buswire, pull up, pull down, my memory tests, and my flash tests. So I click generate. It's going to create tests and also create summaries. So let's see what we have. Nets with only scannable pins means pure boundary scan nets, only about 56. Nets with some boundary scan capable pins, about 266. Nets with no scannable pins is 27 or 7.7% of my board. So that means my power and analog sections more than likely, and maybe some digital stuff that just doesn't have the boundary scan capability is included in that 7.7%. So no matter what I do, I'm probably not going to get coverage on those. So total nets 349. Fully tested in general means we're able to look for open faults, open and short faults, I should say. There's some subtleties to it, and we have a whole list of what it means to be fully tested in our documentation for this software. So if we look fully tested, we have about 319 nets, or 91.4% of our board. That's actually pretty good. Partially tested means shorts only, or in general it means shorts only. We have about 3.4% of that, which means that we're able to get testability on about 94.8 nets. We've only got about 18 nets not tested at all. As far as pins, we have 525 boundary scan pins available to us. So our boundary scannable pins is only about 42.5% of devices on the board or pins on the board. Non-scannable is about 57.5%. but using that, we're actually able to get very good net coverage. So at about 94.8% tested nets. We'll also see non-scannable pins. We are able to do fully test non-scannable pins, meaning non-boundary scan pins, like our memory devices and things like that, about 25.4%. And let's see, partially tested non-scannable pins, 26.7%. So we're able to make up almost half of those, half of the board, using non-scannable pins controlled by scannable pins, at least getting shorts type coverage on it. So that's the summary. If we want to look at the reports, we can go view reports. It will cascade the windows. You can also maximize them so that you can look at one report at a time. If I go window, I can choose the report that I'd like. If I go more windows, it will show me all available reports. So let's see, my favorite is Nets and Pins Coverage Detailed Report. And hopefully this is visible. It should be large enough. The AMD Flash Byte N. So we can look net by net, and each net has multiple pins on it, unless of course it's a single pin net. So here we have a net AMD Flash Byte N. It has boundary scan capable pins on it, so it's being labeled as a BS net. We get complete coverage on the net, which means if we have an open fault or a short fault associated with that net, we should be able to detect it. From the pin side, so we have a resistor pack, pin 6. It's a pull-up. We're getting complete coverage on that. Complete again, meaning open and short type coverage. For U3.80, it's a boundary scan pin. It's bidirectional, so in plus out. We're able to get complete coverage. But on U11 F6, we don't have control of it, so it only gets partial coverage. We can't change it to high and low, so we cannot change it. We can't get an open coverage type result. To get opens coverage, we do need some sort of feedback when changing something. So you need to be able to wiggle something high and low to be able to get opens coverage on it and call it complete. We can go through this whole thing and you'll see every net on the board is classified. So if you have a specific area that you're concerned about, you can check out these reports and see what kind of coverage you're getting. Another one that I'd like to draw attention to is, and this is a relatively new report that we created, unassigned JTAG pins. So let's say that we're done with our first pass at schematic. We're going to layout. What this report is telling us is that U1.5 is not being used. It's like a no connect in our system, but it's a boundary scannable pin. If we think about what a boundary scannable device is to us, depending on your perspective on these things, it kind of is like an internal test instrument. We have 1, 2, 3, 4, 5, 6, 7 IOs just sitting there that we could be using for test. So we could connect these to something else. In the case of U1, this is a PLD, so we could program the PLD for that just to be a don't care, and then we can use it for boundary scan capabilities. In the case of this processor, we would want to make sure that it's not going to interfere with anything if we connect these up, but you could use these as like almost additional test points, additional virtual test points on the board. And that's what's great about that report. And let's see, which other ones do I want to show you? If I go to more, I wanted to show you, those are part of the summary. This one I just showed you, pins per device, partially tested, completely tested. Actually, the one that I want to show you is, it's actually not listed here. So I need to go to my project folder. So documents, Corellis, TPG projects. Notice that I'm working with a flat directory. You can also specify in the software to put things in subfolders. But the report that I want to see is net or test point recommendation reports. So let's look at maximum test point recommendation. It's going to open it in Excel. This is a CSV file. This is a list of nets that we are not getting complete boundary scan test coverage on. So we just saw that AMD flash byte N is not getting complete coverage. So maybe we want to include this in our test points. We want to make sure that when we do go to layout, that we're going to put a test point on that signal. So this is the report that says these you're getting some coverage on, or really it's saying you're not getting complete coverage on these. You might want to have a test point on it for other things. Whereas the minimum test point recommendation report, and I really hope I'm not doing this backward, and yeah, okay, I'm not, good. In the case of the minimum test recommendation report, these are the nets where we get no coverage on, that you are not going to get boundary scan coverage on these nets. You really need to test them elsewhere if you need net coverage. And when I say coverage, I'm talking about test coverage, the capability of having some sort of test for those. When we talk about fault coverage, we're going to get, in general, open and short type fault coverage. In these cases, we are getting neither open nor short type fault coverage. So you might want to look elsewhere for your testability of those. So DFT Analyzer can be used to take a look at the type of testability you're going to get and look into details to determine maybe you can use boundary scan for things you didn't realize, that you can get some boundary scan coverage on certain things, or you're not getting the boundary scan coverage that you need, so you may need to look elsewhere. So I know many of us, we work on designs that have a mixture of analog and digital. Boundary scan is generally only going to get you digital coverage. Sometimes we can make analog things happen by controlling digital nets, for example, with a DAC, but otherwise, we do need separate coverage for analog and digital. We do have customers though that make highly analog products, but they do have a digital subsystem with a DSP and a CPU, maybe some memory, and they are able to get some coverage from boundary scan to make sure that those subsystems are working correctly, or at least structurally correct prior to going on to functional test. I also want to show, let's see, we have these diagrams, so you can view this as a diagram if you'd like to paste that into a report or something like that. It's the same data, just in a different format. If I go once again to generate prior to viewing reports, oh, I have one of these files open, I gotta close it. There we go. If I click on report edit, click add, and I can edit my report. For example, if I have a test point, I can add that I have a test point there and that I'm gonna get coverage elsewhere. If I have a device that maybe is part of my test jig that's not really part of my board, I can remove it so that it doesn't interfere with my coverage results. You don't want to use this to, for example, just go net complete and add complete coverage to all your nets just so it looks good. That's bad practice. We want reality here. And that's DFT Analyzer. Thanks for watching. For more information, visit our website at corellis.com.